Okay, guys, we have our activity session now running. Please, this is going to be our last for now so that we can move on to other topics. Try as much as possible to walk through whatever we do together. Your grade 11 theorems, make sure you know them. Know all the tips that I gave you. We're going to apply a lot of those tips now. So make sure you get the tips at the back of your mind. It's going to make it quite easy. Remember, these questions that we're going to do today would not be the same questions you are going to come across, but the principles will remain the same. Okay. I'm going to skip this proof. This is what? A tan chord proof. I'm going to skip this proof. If I have time, I'll come back to all the proofs, okay, which we did, but if I have time, I'll come back to it. Yes, I want us to look at things like this quickly. The proofs, guys, they are there, already available. Start practicing now. Start practicing now. Okay, in the diagram below, PWRS, I'd like to quickly highlight. We're going to run through on this, run as quickly as possible. My focus is on the grade 12 work, but I want us to pick good marks here. Don't focus too much on grade 12 and lose the grade 11 marks. The grade 11 marks are quite easier to get. PWRS is a cyclic chord. What should run through your head quickly? What are the properties of a cyclic chord? You must know them. There are 3 properties of a cyclic chord. All right. Triangle PSW is an equilateral triangle. That's very, very important. PSW is an equilateral. What does that tell us? Can somebody just quickly shoot? I don't want to be the one to be giving information. Equilateral triangle. What does that give us? What information does that give away quickly? I'd like to hear from you.
All the sides are equal.
Okay. All the sides are equal. Oh, 1 second. Not now. Apart from that, yes, all the angles are equal. All right. And it means, what's the value of the angle?
60.
All right. Thank you, Lindo. Bukudo, your hand was also held. Beautiful. So which angles are equal? 60 degrees PSW, right? 60 degrees. And W, which is 2 and 3, 60 degrees. TW is a tangent. Guys, are you looking at the skill I'm using here? Labeling. Okay, once I see a tangent already, look at this. Beautiful. I already have one angle. Tangent. And instantly my eyes came here as a chord. Which angle do you think is equal to 25? Without even going to the question yet. I have a 10 chord. W5 is 25. Which angle do you think would be equal to 25? You see, we're just still reading.
S1.
S1. What's your reason?
10 chord theorem.
Ah, beautiful. Guys, are we on the same page? This is just you reading, and somebody will think you're wasting time. No, you would see that we would be getting things done. S1 is 25 degrees, 10 chord. Look, already I have so many angles there. Can you tell me what O1 would be? Let's see. What is O1 going to be?
50 degrees.
Linda?
50 degrees.
Why 50?
Angle at center is 2 times angle at circumference.
Perfect. Do we agree? Guys, if you are lost, please let me know. That's 50 degrees. Why? The angle at center there is 2 times angle at the circumference. We have so many angles we could just get right now. But let's do too much. Let's go back to the question now. Okay? And let's see. All right. Now, let's we don't do too many things. Oops, no. So I want the question now, and let's see how many questions you'll be able to answer. Remember what I told you. This you must get in your first 10 minutes. Reading time, you must be done. Oh, don't you see that we are done? Do you notice? Do you notice we are done here? Sorry. Do you notice that we already have a S1, 25, 10 chord? Do you notice we have O1, angle at center? We are done. Before we even read the question, 10 chord there, 25, angle at center, you would complete all of that. Angle at circumference, we're done. Okay, now let's try to get R1. Where is R1? Oh, R1 is here. I'm sure that's about 3 marks. R1 is there. Anybody wants to take us through R1? I already have it. I already have my R1. Yep. R1. Now, lady? Yes, shoot, Nana.
I think we can predict that there's going to be a long way.
Go ahead, Nana. Let's see. How many marks is R1? 5. Can you see how many marks? 5. So it's a lot. Let me push this a bit. It's a lot of work to be done. It's going to be quite... Yes. Go ahead, Nana.
I would look at the OR and OW, that both of them are indices.
Okay.
And because of that, that means R2 and OW are equal.
Okay, hold on, Nana. Hold on. I want us to work together. You are on the right path. So first you said what? OR is equal to what? OW, radii. Next, what did you say?
I said that R2 and OW are equal.
Okay, so R2 would be equal to what? Let's say W3 plus W4. We're saying the same thing, right?
Yes, sir.
Angles opposite what? Equal sides. You're going the exact way that I would have gone. Next.
Then I would say 50 plus R2 plus R3, W3 and W4 equals 180.
Okay, that's a long way. Just say 180 minus 50, right? And then we divide that by 2, which would give us what? 65, I think. $65?
Yes, sir.
Okay, guys, beautiful. You are moving perfectly. Next.
And then I would look at angle P and angle R as a whole.
Okay, so angle R as a whole would be equal to what?
Will be equal to, basically, we are looking for R1. So we're going to split it into R1 plus R2. And then plus P, angle P should give us 180 degrees because of opposite angles of a
cyclic. Okay, so can I say R equals to 120 degrees? Opposite angles of cyclic chord, right?
Yes, sir.
Opposite angles of cyclic chord. Now that I have that, I think we then know our R1 plus R2, right? And what will that give us? Since we know R1 and R2, what is the value of R1?
It's going to be 55.
Okay, 120 minus 65, and that will be 55 degrees. It's not long. That's the perfect way to do it. Perfect way. Guys, let's discuss. Anybody with a question? Anybody with another way? Thank you so much, Naledi. Well done. And you see how I wrote all your statements down. Perfect. Guys, let me know. Thumbs up, thumbs down. You are lost. Quickly, we got to move. Everybody on the same page with me? No questions, right, guys? Great. This is grade 11 work. We get all the marks. Check. You are sitting on 9 marks there without wasting so much time. Okay, there's one more question here, I think. Let me write all the angles that we have. I don't know if somebody is still writing this, but we're good. Thank you so much, Naledi. Great job. Great job. What's our next question? Prove that SP is, and remember what I told you, it's about the skill. Don't waste time. Prove that SP, I'm cleaning this. I want to know if we are okay. Taking that out. You let me know if you want me to go back. Prove that SP is parallel. Guys, please, when you see this question, don't do too many things. First, for them to ask you to prove, it means these lines are parallel. So I'm going to go to my diagram, and you know what we use here? Point number 3. We use the if statement. So I am going to go and say, okay, let's see. If SP is, let me use red. If SP is parallel to TW, where's SP? Okay, SP parallel to TW, what should happen? I'm thinking about my fun angles. So I'll come here and do that. What angles what are you looking at? I'm thinking, okay, let me hear you. Let me hear you. What are you thinking? I've seen 2 things, but I want to hear you. Think about, look at your F, look at your U, and look at the N. And I think we can prove so many things here. Come, people. F-U-N.
Alternate angles.
Okay, which alternate angles? Let's see. Which angles do you want to prove now if you're talking about alternate? Yes, talk to me. You can't just tell me alternate. Lindo, Kwesi. Yes, Mohammed?
If you look at W4, then that will mean that W4 plus W5 equal to 60.
W4?
So you say angle S2 is equal to angle W4 plus W5, alternate angle.
Wait. Hold on. Come back, Mohammed, guide me. You said we want to prove alternate angles. So we're saying if SP is parallel to TW, which angles are you focusing on? Which angle should equal to which angle?
S2.
Okay, so you are saying then S2 should be equal to what? W4. Do you understand my statement? If SP is parallel to TW, then S2 should be equal to what? W4 plus W5. So we know this as what? 60 degrees. Our job will be to go and prove that this is what? 60. Okay. So we have a mission, we have a vision, and we have a goal. Now, Mohammed, take me through your W4 and W5 now. I want to prove that it is 60. Oh, by the way, we know this angle, right? Always write the angle that you have. It's going to guide you. Remember, we have this angle from Naledi's explanation, 120 degrees. Yes, Mohammed, go ahead.
Yes, sir. So you can see that W4 is equal to 35 degrees. You see sum of angles in a triangle.
Okay, so you are saying, let me go ahead with you. W4 is equal to what? 35 degrees. Sum of angles in a triangle. Yes, go ahead now. Let me write this here.
W4 plus W5 is equal to 60.
Oh, I see where you're going, because already we have that. Now, so W4 plus W5 equals to what? 60 degrees. Good. Then what are you saying now?
S2 is equal to W4 plus W5 is equal to 60 degrees.
Ah, you're so smart. W4 plus W5 is 60, right? So therefore, we have proven. Do you see we have a mission and we now have accomplished it? S2 equals to what? W4 plus W5, which is equal to what? Oh, by the way, we needed to state something. Why is S2 60? We need to state that. Equilateral what? Triangle. So W4 plus W5 equals to S2. We can now make a conclusion that SP is parallel. When we do parallel lines, we don't use the word converse, right? We just go straight and say alternate what? Angles. Did that make sense, everybody? Are we on the same page? Did that make sense? Okay. I was actually going to use okay, let me talk. Yes, Victoria?
Hi, sir.
Hi, Vicky.
Sir, I was going to use W1 as well.
Okay, I was also going to use W1. So take us through your W1.
Sir, I said that W1 is equal to S2 10 quadrillion.
W1 equals to what?
S2.
Oh, magical. Magical. So W1 would be equal to what? S2 tan chord, yes?
Yes, sir. And then we know that angle P is equal to 60 as well.
All right.
Therefore, W1 is equal to angle P.
Okay, beautiful. Magical. That was what I was going to do as well. Awesome. Awesome. Okay, any other guys, did you get that? Did that make sense? Do you see what she said? She was using what? Okay, so that you all will see quickly. If that, then this is what she's saying. She's saying if those two lines are parallel, then W1 would be equal to P. So this is what she's aiming to prove. When you do this, it makes it easy. You are now trying to prove that W1 equals to P. So already P is 60 degrees. Remember? Equilateral what? Triangle. Now W1 equals to what? S2. Oh, by the way, we don't know S2. So you have to also tell us that S2 equals to 60 degrees, equilateral triangle. So W1 is now equal to S2, which is what? Tan chord. So P equals to W1. Therefore, SP is parallel to TW. And what's your reason? Alternate what? Angles. Are we on the same page? And check here from what Mohammed did. That's why when you think about fun, you think about all the three. I could also use this one. Look at this. Because we have 60 here, right? Yeah, we have 60. Good. We have 60 here. We have 60 here. That makes it 120, right? Are you seeing that? 60, 60. Can you see that it's 180? Co-interior. So I have 60 and I have the whole of this as 120. Co-interior angles. Any other person? Are we all okay? So please, the skill is what I'm trying to show you. Once they say prove this, just quickly do your own story to say, okay, if this is parallel to that, then this angle should be equal to this angle. You are not all over the show. You are not all over the show. You're getting it as quickly, as swiftly as possible. Well done. Grade 11 work. Oh, beautiful here. I don't know if you guys were able to. Did you have time to do this? When I see this, I'll tell you what comes to my head straight. Theorem 1. Just by the look of the diagram, Theorem 1 straight. Let's run through together. In the diagram below, a circle centered at O is drawn. All right? H, J, G, L are points on the circle. Triangle, is drawn. H, O, G bisect. Without even reading the diagram, the question, you can see line drawn from center that bisects a chord is perpendicular. I don't know if you get that. Once I see that diagram, the first thing that comes to mind, Theorem 1. And when I see Theorem 1, I know Pythagoras could be something to do. If MG is 6 units and OM is X, let's go there and write it. OX and 6. Write down HM. What do you notice about HM? Very beautiful. Please, guys, always write out what your radius is. Do you notice that from here to here is radius? And I can see quickly that my radius, check. My radius is OG. And that is what? 6 plus X. Do we agree? Let me know. Do you agree that that's my radius? Talk to me, everybody. But what am I looking for? HM. Oh, so HM is my radius plus OM. And what is my radius? 6 plus X. And what is OM? OM is also X. So what's my answer? 6 plus 2X. Everybody okay? Okay, we're good. Calculate, given reasons, the length of the radius. Does anybody have an answer? Did anybody get an answer? Yes, Nalady?
I want to know how is OH only 6, only X, isn't supposed to be X plus 6, because if OG is like the whole radius, shouldn't it be like people saying for OH as well?
Wait, what did I saying? We said the radius is what? 6 plus X, right? So, HM is HO, my radius. Oh yeah, I made a mistake. No, it's fine. I'm correct. Check here, lady. So what is my HM? Let me get a highlighter. No, I'm looking for HM, right? Which is this? Right? HO and... Do you see that? And my radius already is 6 plus... So 6 plus X plus X. Okay. You are welcome. What about the next question, guys? Don't even panic here, guys. Once you see Theorem 1, don't even make noise. And Theorem 1 goes with Pythagoras. Look, I don't know if you can see that triangle. And what is this? 12 root 5. And what is this? 6 plus 2x. This is OMJ. Because all I need to do is to get my value of x. Does that make sense? Let me know if that makes sense. Please talk to me. Line drawn from center. That bisect a chord, which makes triangle OMJ is now a right angle triangle. Then I can work out my Pythagoras now, which is what? OJ squared equals to JM squared plus O. Please make sure you write that word, Pythagoras. I'm going to need you to get me the algebra now. 12 root 5 equals to 12. Don't forget, all of this is squared, plus. Okay, come, algebra now. Quickly. And let me know if there's anyone with a question. Let's work out the algebra. Yes.
So how is OG 12 root 5?
How is?
OG.
Oh, sorry. It's not O. It's H. Sorry, my bad. Thank you, Lindo. It's HJ. HJM. So let me change this. HJM. All right, I'm waiting for you to give me answers. Algebra. Why is it taking us so long, right? It shouldn't take us so long. You're looking for the value of x, then we go and find our radius. Victoria says x is 9. Is there anyone agreeing to that answer? Lindo also says x is 9. I need one more person so that we can then move. Venusia also agrees. Okay, let me confirm. 12 root 5 times 12 root 5. What would that give us? That would give us 144 times 5. Anybody wants to help me there quickly? 12 root 5 would give us 144 times 5. Somebody help me there with an answer. Type it in for me. 720. All right, so 720 equals to 144 plus what? 36. 6 times 2, 12, 24x plus what? 4x squared. Now, what is 144 plus 36? Do you want to help me with that? 144 plus 36 would give me 180, right? And what is 720 minus 180? Anybody? 720. So you're saying 144 plus 36. 5 what? 540. Okay, so minus 540. So this gives me a trinomial. I think I can divide by 4. I know some of you used quadratic, but that's one formula that I'm lazy to use that formula. Okay, so let me divide by 4. If I divide this by 4, what am I going to get? 160, right? And if I'm looking at 160, what are my factors? Yes, talk to me. Is there a hand there? Yes, talk to me now, lady. Sorry?
135.
135?
Yes, sir.
You sure?
Yes, sir.
Oh, the holiday is in my head. Okay, so what are my factors? Oh, guys, yeah, I'm correct. Divide that by 4. 4 times 6 is 24. 4 there, 1. All right, you're right. Okay, two numbers, 135. What are my factors? Anybody? Let me show you, for those that will do MBT, let me show you how to find factors without a calculator. Would you like that? Without a calculator, and you want to do MBT. 135. Check here. Divide by 5. What would I have? Divide by 5 would give me 2 there. That's 10. 35 would be what? 7. So I have 3. I have 3. No. 3. I have what? 9. I have 3. I have 3. All right. Is this correct? Something is wrong. What am I doing wrong? 37. 3 and 27. But 9 times 5 will not give me 135. Oh yeah, no, not 9. 127. All right, beautiful. So then you combine. Look at 5 times 27. But if I'm checking 5 and 27, it will not give me 6. Okay, then you combine another set, 15 and 9. Oh, that would give me 6. That would definitely give me 6. If that is not working, I would say 3 and 45. But I'm looking for 6. 15 and 9 would give me 6. So that's what we do without a calculator. 0, x. I'm looking at 15 and 9, right? And I want, so it's positive 15 minus 9. X equals to negative 15. X cannot be equal to a negative value. It's a distance. So x equals to 9. So for those of you that are doing MBT, are going to do MBT and you require that, that's a free lesson for you. But what is my radius? Radius is 6 plus x, which is what? 6 plus 9. And that is 15 what? Units. We're good? We're good, everybody? Fatima, thank you. 9 and 15. Okay. Everybody okay? So guys, once I see theorem 1, I know that I am walking through Pythagoras what? Theorem. In line, you must first prove that it's a right angle, and then you walk through. Beautiful. Lovely. If you need me to go back, I'll go back later. Ooh. There we go. Now let's do the real stuff. Let's check this one. Let's see. This is 8 marks. Looks like it's going to be interesting. We'll take it together. In the diagram below, P, Q, R, and S are points on a circle. PS, PQ, PR are produced to VT and W respectively. Please check this line. Look at the last line. VT is parallel to SQ. Look, let's go trace that. And that is going to be our key. This line is parallel. What do you notice? I have 2 parallel lines within a triangle. Can somebody quickly tell me what property, what am I using, what comes to mind? We've not even read, but just seeing that, what comes to mind? Anybody? Unmute yourself and talk to me. Once I see parallel lines in a triangle, what comes to mind? Good. Parallel lines in a triangle. I am quickly thinking proportionality. Proportionality. That's the first thing I'm thinking about. Okay, and I see two of the triangles. Beautiful. Prove with reasons. TQ over QP. Go and trace it first to see what you're going to do. TQ there over QP. Oh. And they want us to prove what? WR. Where's WR? Ah, nice. My good learners, let me see something. Please give me a response. Do you see what to do? If yes, give me a thumbs up. If no, thumbs down. I just want to check something. Do you see what to do? Okay. Almost everyone. Only one person gave me a thumbs up. My good learners, I'm going to slow down now. I want us to watch. Trace the triangles they gave you. TP over what? QP. Okay, wait. Do you notice that already falls in a triangle? Do you notice that, right? TP. Please let me know. Do you have thumbs up for me there? That's the first thing I'm looking at. All right. Now watch the next one. They said I should prove that it is equal to WR over what? RP. Oh, wait. Do you notice that that comes in another triangle? WRRP is VSSP. Watch this. And VSSP is, I don't know if you see it already. Do you see? Talk to me. Look at my highlights. I'll repeat if I need to repeat, but do you see my highlights? Let me repeat. 1, 2 is equal to that, but that is equal to that. One side has a relationship with two different sides from two different triangles. So I'm done. 3 marks. I am so done. TQ over QP. Let's consider, let me write the triangle so that it's easy for us to see. Consider triangle PTV. QP, no, they want TQ. Let's follow them. Follow the order. TQ over QP. Does somebody want to tell me what I should write? What is TQ over QP? Anybody?
VS over SP.
VS over
SP.
SP. And what's my reason?
Theorem.
Proportionality theorem. Thank you, Rati. But it's not complete, remember? It's not complete.
CV parallel to QS.
TV parallel to what?
QS.
All right, we're done with the first one. Now, what do you think I should do again? What did we connect? We connected our VS and SP. Oh, let's write a triangle for clarity. I'm looking at my second triangle now. PWV. Okay. That VS and SP we got in our first equation. Anybody wants to help me? What should it be equal to now?
WR over RP.
WR over RP. And what's our reason? Proportionality theorem. Don't forget, it's not complete. Talk to me. Complete it.
SR parallel to beta wave.
Okay. Now, do you notice? It's almost as if you're doing simultaneous equation. TQ is equal to, so I can just replace it. Instead of writing VS, therefore, TQ over what? QP will be equal to what? WR over RP. Did that make sense? 3 marks. Did it make sense? Everybody okay? Becoming clearer as we do more activities? Lovely. All right, 9.2. Prove that, let me give you a moment to write. Give you a moment to write. Prove that TPVW interesting. It's a cyclic quad. Are we done writing? I'm sure you're done writing the first part there. Okay, I want to answer this one. Can you tell me, guys, when you see this, give me the properties of a cyclic quad. Let's go. 1, 2, 3.
Angles in the same segment.
Angles?
In the same segment.
Okay, angles in the same segment. Yes, any other person? Oh, Vokuda, thank you. Opposite angles are supplementary. Yep. Yes, the third, I need the third one.
Exterior angle is equal to opposite interior.
Exterior angle is equal to opposite. Oh, you guys are the best. Lovely. Now let's go look at the, are we done writing? Because I was using that to just wait for you and revise. Are we done writing? Are we done? Okay. On my list of tips, I told you that if they ask you to prove a shape, a line, what do you use? If statement. So I'm going to use the if statement to say, okay guys, so here's my thought. I want to write this down. So when you are doing this, you just put this as a little note for yourself. This is not part of your answer, but it's what this is what will give you clues to getting your answer. Check this. Since they said I should prove that that is a cyclic quad, if TP VW is a cyclic quad, what can you tell me? Looking at these 3 properties. Please check. T, let me help you with this. TP VW. I'm allowed to do this now. I want to prove that that shape is a cyclic quad. What can you tell me? I've already, if you can see that. Yes, somebody talk to me.
Angle T is equal to angle W.
Angle T, which T? Let's label it. T1, T2, W1, W2. Which one are you referring to?
T1 and W2.
Okay. T1 should be equal to W2. What would be your reason for that?
Angles in the same segment.
All right. Angles in same segment. That is 1. But I think I could still prove a lot more. I'm not saying we should do everything. I could prove that V1 is equal to P1. All right. Same angles in the same segment, but we don't need to go there. Let's work with what Mohammed has started. Can we work with T1 and W2? Anybody? Anybody? Do we see where to go from here? Don't forget those parallel lines. They mean a lot. Ooh, I just finished. Can I help you quickly for 10 seconds and I'll leave you? Mohammed has given us a very, very good starting point that T1 is equal to W2. Everybody, go and focus on T1. Boykayo, how are you?
Sir,
Yes.
T1 is equal to Q1.
Okay, hold on. Take us through gradually. Take us through. You're there. You're saying what? T1
is equal to Q1.
Can I use letters? Can I use letters to show that? So if this is X, this will also be what? X.
X.
What's your reason?
Corresponding angles.
I don't know if we all follow through. Are we following? But can I just, I want everybody to follow you. Those lines are parallel. We see that, right? Corresponding angles. Okay, great. They say they are with you. Next.
And then W2 is equal to R1.
W2 is equal to R1. What's your reason?
Corresponding angles again.
Okay. Then what would you do after that? Because I thought, no, now the main link, you left it. But can you, come, let's go. You got T1 is equal to Q1, right?
Yes.
Now focus on Q1. What is Q1 equal to? Grade 11 theorem. Come on, Papi. Okay. Anybody wants to help? Wait, can I, before you go on, before everybody helps, Boykayo, can I show you something?
Yes.
You've given me this, right? Can I call this Y? And I call this Y?
Yes.
Just use common sense now. Why do you think X and Y should be equal?
Because the angles in the same.
You are done, boy.
Yeah.
So now let's walk it back now. So T1 equals to Q1, right? But Q1 is equal to what?
R1.
And then R1 is equal to what?
W2.
Do you see we are done?
Yeah.
Guys, is it making sense when I say the skill? First analyzing, and then you know what you are aiming to prove. You're not just going everywhere. You are limiting what you should do. Somebody is busy with P1, P2, S1, S2, No. Now, if I need to write my statement, I just go the exact way. Angle T1 is equal to what? Angle Q1. What's your reason? Corresponding what? Angles. Why? QS is parallel to PV. But that same Q1 is equal to what? R1. Angles in. So, Bokai, once you think like that, then know that those angles are equal. Find a reason. Now, R1 is equal to W2. Corresponding what? Angles. Angle RS is parallel to WV. Oh, we are now back here. Yes, talk to me. There's a hand. I can't see who that is. Talk to me. Yes?
When you do this where you say the angles are in the same segment, if you could highlight it for me, please, sir.
Okay, when we say angles in the same segment, think of a butterfly, right?
Yes, sir.
Q1. Does that make sense?
Yes, sir.
Done.
Oh, okay.
All right.
Thank you, sir.
You're okay. So we can now, since we now see we have proven this, that was the aim. Therefore, TPVW. Yes, talk to me.
So can you please explain how R1 is opposed to W2?
Corresponding angles. Parallel lines. Do you see parallel lines?
Yes.
That's
okay. Thank you.
So every time you see parallel lines, just make a note. I should be working with what? Fun angles. Now, what's our reason? Because we use the if statement, we come to what? Reason. Converse. Angles in same what? Segment. Thank you, Bokayo. You saved us. Let me take any other question, any other person. I want us to explore. Any other person with a question? We got it? Everybody okay? Every one of us looks good. Awesome. Awesome. Good job, guys. Good job. I actually like these questions. They're kind of good. They build gradually. Okay. Are we done writing? Anybody still busy? Okay, let's look at the next one. Are we done here? Ooh. We're going to start gradually here. Let's start with this first 10.1. Did you have time to do this? Did you have time to do this? All right, I want to give you 10 minutes. This is 8 marks. Look through. Look through. You have the question as well. Okay. I may advise you quickly, draw this circle on your page so that you can annotate and write on it. Draw it out on a page. Doesn't have to be perfect. Draw it out on a page so that you can annotate and write. Let me give you 10 minutes to try. Explore, guys, explore. Let's explore. 10 minutes. Don't get a 0. We're going to mark together. Hi guys, did you manage? Oh, I'm seeing some hands. Okay, let's see who struggled. Who did not get an answer? Give me a thumbs down. I want to see. Because if we all got it, then I'm just going to run over it. I won't be as slow. Okay, 1, 2, 3, 4. Okay, 5, 6. All right, not bad. Guys, it's about the skill. I'll tell you why you did not get it if you did not get it. You are looking all over the place. And that is what this session is for. Don't look all over. Don't look what? All over the show. Don't be all over the show when it comes to Euclidean. You're going to be confused and you're going to mess it up. Start by reading. In the diagram, BCD are points on the circle such that BC is equal. Look, first, BC is equal to CD. I already have my D2. Does that make sense? And that's why I told you to draw and make notes. Guys, what is D2? Do you have D2 already? Talk to me. Especially those of you that said you did not get it. Already I have D2. Angles opposite equal sides. It's an isosceles triangle. Already I have this. I don't know if I'm going to need it, but I have it. BC produced, EC and CD are tangents. My good learners, come, let's go check. EC and CD or ED are tangents. Okay, let's see those tangents. EC and ED. Oh, there's a theorem here. I don't know if you remember the theorem. Anybody remember the theorem? I see two tangents. Anybody remember the theorem? We spoke about it when we spoke about tangents. Tangent, there are three things. Let me remind you, a quick crash course. Hold on, Mohammed. Is that Mohammed? Hold on. Let's talk about tangents. What are the things to remember about tangents? There should be three of them. Come, let's revise. 1, 2, 3. Give me one.
Tangents at a point. No, that's measured at the same point.
Okay, we say tangents drawn from common points. Tangents drawn from what? Common points are equal. Yes, number 2. Anybody about tangents? We're revising, so we extend. Number 2 about tangents. Come on. Speed. Thank you, Lindo. You're such a star. 10-chord theorem. Next. There are 3 of them. Let's revise. What's the third one? All right. Tan perpendicular to radius. Okay. In this particular one, which one do you think will apply? T1, T2, or T3? T1. Okay, hold on. At this point, so we know that EC is the same as ED. Let me know if that makes sense. Tangents drawn from the same point. Look at analysis. Tangents drawn from the same point. Which forms a what? An isosceles triangle. It means my C2 is the same as D1. My C2 is the same as D1. Okay. Can I get any of the two? Because check. Now look at the question. Examiner says, go and prove that E1. Let's look at E1. You would notice E1 is here. Where? Just check. It's in a triangle. Oh, I am done. Do you notice E1 plus C2 plus D1? You got to be smart. That's a triangle. I know that these two are now equal. All I need to do is to find them. Can C2 be equal to X? Can D1 be equal to X? Let's see. always label. That is a tangent. That is a tangent. Oh, and that is a chord. I'm looking for that. Tangent, tan, chord. This angle. Okay, which chord? Chord CD. Where does it go to? X. Please let me know if it's okay for D1 to be X and you are not lost. Tangent, chord. D1 is the angle between the tangent and the chord. Then I look at the chord CD, right? That's the chord I'm using and the tangent. Where does chord CD lead to? It leads to angle B. Talk to me. Thumbs up, thumbs down, especially those of you that got lost. So we agree that D1, I'm done already. That I now know that my D1 equals to X. What's the reason? Tan chord. I'm going to go a different way from when I started. Do you notice that C2 is also equal to X? Tan chord. Do you notice? Let me show you. I just saw that. So I have many options. Tangent and a chord. Angle between them. It's the same chord CD. Oh, CD goes to X. So I am done with this question X. So we actually proved that those two angles are equal in two different ways. Now I can therefore say E1 equals to what? 180 minus 2x. Sum of angles in a triangle. 3 lines and I got my answer. Nothing else. That is just one way. That is just one way. But I think I don't know if you did something simpler than this, but I think that is just quite straightforward. That angle D1 equals to X, angle C2 also equals to X. Both using tan chord theory. There are other ways, like I said. Did this make sense? Did this make sense to you? Quite a few of us were a bit confused, but did this make sense now? So guys, don't look everywhere. Read first. As you are reading, analyze the theorems. Go to the question and see what is it that they need and start merging things so that you don't waste time. I won't waste time by looking at other methods. Those of you that got it through another method, lovely. But I have quite a number of questions to do. All right, triangle ECD. You should know this one. Do you remember what we said? What's the first thing we do? We list the angles in order. ECD. Come, let's go. ECD. What is that? Do you notice the angles? What's the first one? Anybody? What's the first one? ECD. I don't want to do the work. I'm waiting. List it in order. Anybody? Oratile, you want to talk to me? List the angles for me in order.
Okay, so EC is equal to...
Use the skill that I taught you. How do we list? My tip says when you see similarity, list the angles in that triangle in order first before we start writing answers. Follow the thing that I taught you. You're going to make it more easy. So I want us to learn that. Yes. Well, actually, that means you didn't get that point. You didn't get that point, and it's going to be quite challenging as we go on. I want you to work with those points. Anybody? Do you want to list? So, yes, who's that? Kwezi? No. List. That's what I said. List the angles in this triangle for me. ECD, list. Let's do it step by step. It's going to make it easy. Least. Can we do you know what it means to least? There are three angles. Which one is the first one, second one, third one? That's all.
Oh, so it's E?
It's not E. It's not just E.
Oh, so ECQ.
E1. You guys, it's E1.
Angle E.
It's not angle E. It's angle E1.
Okay, C2.
Yes. If you follow those skills, and then what? That's all I'm asking for. Follow those tips, guys. If you can follow what I'm teaching you and do it exactly, it's going to be easy. List the angles in order. Can you list for me CBD now? Quickly. And with the letters, let's trace it. C, B, D. Give me the angles. Now you are doing maths. You would enjoy maths now. C3.
B, I don't know.
It's just B. It's just B.
Okay, B and then C2.
Thank you. You are now doing maths. Simple. You see, you're not looking everywhere. Follow these skills. Do we know E1? We got
180 minus 280.
Okay. Which angle do we know again? Do we know C2?
Yes, which is X.
It has been proven. Do we know D1?
Yes, X.
It has been proven. Do we know D2? We wrote it in blue.
Which one? Which one, sir?
D2.
It's X.
Good, we know it. Do we know angle B?
It's X.
That has been given. Do you notice I'm already done? Even if I don't look for C3.
Yes, sir.
That's the skill I'm telling you, guys. No matter how much you think you know it, follow the skills. Life becomes easy. And you won't waste time. Alright? So I'll go now and say C2 is equal to X. Check. C2 equals to X. That has been proven. And I know it's equal to B, right? B equals to X. That is given. So I can pair those two. Alright, let me first write all the individual angles. What's our next one? D1 is X. That has been proven. D2 equals to X. That is not proven. We had to get that by saying angles opposite equal what? Sides. Now I can pair these two. Do you see I've done the rough work? C2 equals to angle B. Angle D1 equals to angle D2. Therefore, angle E1 must definitely be equal to angle C3. What's my reason? Third angle. I can then make my conclusion. Triangle ECD is similar to triangle what? CBD. Angle, angle, angle. Guys, it's not about this particular question. It's about the skills that allow us to get all the answers quickly. Anytime I see similarity, list the angles in order. Once I list them in order, I know they are equal. Try to find a reason for their equality, and you need only two. The third one, write third angle. And you are done. Don't forget your reason. Angle, angle, angle. Everybody okay? Euclidean, the most dangerous topic becomes the easiest to us. Follow the tips. Okay. And what did we say after this? You should write your ratio. So I'm going to write my ratio. EC. Can somebody continue for me? EC over CB equals to? Who wants to continue more? Okay, Mohammed, go ahead. I see your mic off. Yes?
CD over ED.
CD, number 2, number 3 over number 2, 3 on the right side. Yes?
ED over CD.
ED over what? CD.
CD.
Guys, be very careful of the lines that are equal here. You see here, they're going to play a lot of tricks on us. I see too many lines that are equal and it might create a problem. Okay, let's get the next part of the question. We want to get the next part of the question. This is 10.1. I'm enjoying these questions. They're just nice. Please, I am more interested in the skill that we are using than the question itself. It's going to help us get the answers very, very quickly. Now, let's pop the next question out and also pop out answers in getting the question. Okay. There we go. There's a 3 marks question and there's a 6 marks question. My good learners, let's work. Prove that. Okay, let me do this. 3 marks and 6 marks. I'll just write the mark allocation close to it. Three marks and 6 marks. Prove that the first one. Guys, let's first go look at our question again and try to tick off on the ratio. Examiner wants CD squared. Look at this. The only way to get CD squared is to have what? So look at, I'm going to work backwards. Kwesi, you asked me one day, the first day I taught you about the skills. How do I work backwards? Check. For me to get CD, do you notice that, right? I have to cross multiply. Then, just distribute the other one. I don't know if you see your answer already. Do you see your answer from the ratio? I want CD and CD. It's already there. I want BD and CE. BD? Ooh, wait. I want CE. But what do I have? ED. Can you connect both of them? Go back to the diagram. Is ED equals to CE? Yes. Can you see? Tangents drawn from the same point. So I'm done with this question. I don't know if there's anyone who is lost. From my ratios, I'll come and say check. I'll write the one in pink first. CD. I don't have to write the whole ratio. ED. That is coming from my previous question. And what is my reason? What is my reason? Similar what? Triangles. You can cross multiply. CD squared equals to what? ED multiplied by BD. But ED is the same as CE. Why? We did that at first. Tangents drawn from common points. So I can replace it. Therefore, CD squared, instead of writing ED, let me know. Are we good? Did it make sense to you? Did it make sense to you? Questions? Let me see. Mohammed, looks like you want to ask something.
So then, before we start the question, it says BC is equal to CD.
BC. But will that help us here?
Yes.
How?
CE is already there.
Huh?
CE is already there. You said BC is equal to CD.
Yeah, but do we need it here?
No, you could have done it instead of saying that ED is equal to.
Okay, wait.
CE.
What would you have done? Let's see. What would you have done? Show me what is in your head. BC is equal to what? CD, right?
Yes.
And that's BC. So I would have what? EC over CD is equal to, if I cross multiply, do Do you notice it's not giving me what I want? Except you now, oh, it is. Oh, it is. Oh, yeah, CE. Oh, great. Great. Beautiful. But do you notice it had to also come from our ratio? I didn't even see that. Well done. Well done. I didn't see that. Beautiful. So we have two ways of getting that answer. Mohammed, I owe you something. What can I give you? Okay. But we would have still needed EC over CD will be equal to what? CD over BD. Similar what? Triangles. CD squared equals to what? EC multiplied by BD. Oh, that one is actually easier. We don't even need to equate anything. Yeah, that one is easier. We don't need to equate anything, all from our ratios. Makes sense? Thank you, Mohammed. That one is a lot easier than what I did. So do you see the importance of writing out your ratios now? Once you're done with your similarity, I hope this is teaching us a good lesson. Write the ratios immediately you prove your similarity. Just keep it somewhere. It comes in handy. Can we move forward? Okay, Sina. Hi.
So we need to repeat the whole process again, sir.
The whole process?
Yes, sir.
Okay, where are you lost?
So like the angles,
Which angle? Are you talking about 10.1.2 or 10.2.1? Which one?
the first one that you feel time,
The first?
the first one like 10.2.1.
Okay, it's the same one. I'm still here. 10.2.1.
Oh.
Yes. Check.
The
The examiner says CD, right? Okay, so Mohammed gave us a simpler way and I'm going to go there. The first thing is, once I write my similarity, right? That's what we said. Write out your ratios. Are you okay with these ratios?
Yes, sir.
Okay, let's do this. CD squared. Check. I'm going to mark CD, right?
Yes, sir.
Wait, Mohammed, what did I write now? Okay, watch this. Yes, I got it now. I think I missed one line here. Are you with me? CD squared. CD and CD. Is that fine?
Yes, sir.
Then they gave us CE and EB. Watch this. I'm going to go Mohammed's way. CE and BD. Where's BD? BD and CE. Let me do it on, let's do it on a fresh page for you so that you don't get it mixed up. Okay, watch this. Let's do it on a fresh page. So we have our ratio. We got this earlier on, EC over CB. You said you're okay with this, right?
Yes, sir.
Okay. So let's go back to the question. The examiner wants CD squared. So I noticed that CD, that's CD. Then they want CE and BD. CE. Do you notice where my CE is? Okay, I wrote as EC.
Yes, sir.
Okay. Do you notice that this one is almost complete? All I need is a pair.
Yes, sir.
Okay, so my problem is what?
Yes, sir.
Okay. Let me also teach you something, everybody. When we label like this, let's try to label alphabetically. It's going to make our life a lot easier. All right, label alphabetically. So I should have written my EC as CE. If you notice, that's what they always do. And CB, I should have written as BC. So my problem is this one. But if you go back to what was given, do you notice that BC is equal to CD?
Yes, sir.
Okay, so let's change it. Let's write it nicely. CE alphabetically. Instead of writing BC, BC is the same as what? CD. Are you there?
Oh, yes, sir.
Because it's given. First line. And then I have CD and BD. Do you notice if I cross multiply, I'm done? CD squared equals to what? CE multiplied by BD. All right. Okay. So once you are done with your similarity, write your ratios. Okay, my good learners, the last one. Don't be scared of the marks. And like I always say, last one it may be challenging, but at least you have gotten all your marks from the top. CF squared, I don't know where they're coming from with CF squared, equals to EF squared. Yeah. We do not have that at all in our ratios. BD over DE. Okay, I see something here quickly. I don't know if it's going to work, but let's go try, and I'm going to work with you. My good learners, I saw something now. Let us try to trace the lines that they want. They want what? CF. Everybody watch this. I want to show you something. CF and EF. Okay, first thing I see, that's a triangle. But look, you are doing math for a long time. Do you think we can prove that these two lines are parallel? Because that's what you are looking. You are looking for some of those things. Do you think those lines are parallel? Why would you say they are parallel? I don't know if it's going to lead us to the answer, but that's what I'm looking at. Would you say they are parallel?
The angle is.
You think so, Fatima? Okay, I have Fatima, I have Vukudo. Fatima, why do you say they are parallel?
Because angle B is equal to angle C2, which is equal to X. So it's corresponding angle.
All right, you have corresponding angles, and I can also use that. Okay, so we all agree that these two are parallel, right? And if they are parallel, I'm starting to think of what? Triangles with two parallel lines. I'm trying to think of corresponding. Do we agree? Such that this line over that line, okay, so CF over BC should be equal to what? EF over what? DE. Do we agree? Prop theorem. Okay, that's what I'm thinking at first. All right, that's my first thought pattern. Thank you, Dente. That's my, because I see examiner is giving me CF. All right. What do I have? DE. Wait, hold on. So I have DE, this is the one DE, but they're giving me BC. Oh, but BC is equal to BD, right? Check. That has been given. Okay, CF over BD. I kind of have all the letters. It's just the arrangement. Do you notice? Before I continue, let me see if you are with me. I have all the letters. It's just the arrangement. Talk to me. Kwesi, where are you lost?
Start by your second step when you change BD.
It's given. BC is the same thing as CD. No. BC. Oh, no, I lied. I saw something different. BC is CD. What do I want? Wait. BC. Oh, I'm lying. They are not the same. Sorry. My bad. Thank you. Okay, let me go back. So I have this. I have that. I have that. Which is what? I have CF. I have EF. And I have what? DE. So my problem is BD and BC. Sorry, my bad. I got excited. BC and what? BD. Woo! Am I right? Can I go back to my letters? Sorry, 1 second. CF over BC equals to what? EF. All right. All right. Okay. That is actually equal to... So my problem is BD, right? All right. Let's try something again. We stuck there. In my notes that I gave you, I told you that if the examiner requires something, what do you notice about this triangle? Do you notice BD is the base? Talk to me, everybody. If you go back to the tips, can somebody quickly run back to the tips? If you don't have the tips, we're going to send it to you. Go to point number 1, 2, 3, 4. What does point 4 say? Can somebody read it? I don't have it on this slide. Anybody with point number 4? What does it say? No. Is it either number 4 or number 5? There's one that talks about the base of a triangle. I wanted to show that it's in your note. If the bases of a triangle are required, prove something. I want you to tell me. Run to that note. If the bases of a triangle are required, prove something. Come now, lady.
Prove similarity.
Wena Vukudo. Come, let's go out for lunch. Wena, I'm taking you out for lunch. So in case you didn't write it down or you didn't take note, if the base of a triangle is required, why base? I see that the examiner wants what? BD. That's the base. Once the base is required, prove what? Similarity. We're going to work very roughly first. Those triangles are similar. Those lines are parallel. And by the way, this angle is actually equal to that angle. And Fatima said something nice. C1 equals to E, corresponding angles. And angle F is the same. So, let's do all the rough work together, everybody. I'm not trying to lose you. Prove similarity. First, angle F is common. FF. Angle C1 is equal to angle B1, corresponding angles. C1 here, B here. Then, obviously, angle E2 would be equal to angle that. In this triangle, E is equal to D. Let's write it. So, F order. I'll re-explain if you are lost. Can I write my ratios now? They are now similar. FC, I will write the letters, first 2 over first 2. Last 2 over last 2. Okay. Now, let me write the letters out nicely, alphabetically. CF over BF, C before E, BD. Okay, my good learners, let's go back to our question. What are we proving? CF, we have CF. EF over EF, we have EF. BD, we have BD. This is a mess. And DE, we do not have DE in this particular one. All right, I see something nice that we can use. Which lines are equal again? EF and BF. Okay, all right. So you would notice that in this particular one, we have something here. All right. This is now slapping us, but it's okay. I see my answer, just need to get it right. What was missing here? BD. BD was missing. Okay, BD was my problem. If I were to use this one, will it work for me? What's my first answer? CE. Like I told you guys, please be careful with all those lines that are equal. There are too many lines that are equal here, so it's going to really cause a lot of problems. CE is equal to ED. Please, those lines are very, very troublesome when they are like this. All right. CE is equal to ED. All right, just checking something. CE, any line equal to DF? No. Yes, anybody saying something? CE is equal to ED, BC is equal to CD. Yes?
I think what the other ratio is the ones that made now, where CE is over BD, we can replace it with ED because that's what we're looking for.
Sorry?
We can replace CE on the thirds.
We can replace what? B?
CE with ED.
CE with ED.
Yes.
Yeah, I see, but I want to check something. Okay, CF, I'll tell you where I am having a bit of an issue. Instead of writing CE, because CE is not in my final answer, what do I have? I have ED, or let's say DE, because they are equal before we merge everything, over BD. Okay, so we have BD and DE, and that is EF over what? DF. So if I go back to my question, I have CF, I have EF, I have DE, and I have BD. So you see, it's trying to merge something for me there. Okay. 1 second, I'm going to get all out of this problem now. We're looking for CF, we're looking for BD. Okay, I have BD there. DE, I have DE there. Okay, and I have CD. CD is the same as CD squared is the same as da-da-da-da. And BC is equal to CD. All right. Yeah, the 6 mark is worth it. But we are almost there. Guys, can you see the way I'm trying to put out all my ratios? Our answer is lying in these ratios. I don't think we need to do anything more. We just need to bring them together. For clarity, I want to write this out. Number 1, we got CF over BC, all right, which is equal to EF. Just want to write all the ratios out over DE. We have prop theorem. Beautiful. That's the first thing we have. Then we came from similarity. We have CF over BF, which is equal to what? CE over BD. Okay. BF, and that is equal to EF over DF. Carry along the first ratio that we have, the first question that we did, CD squared. Carry that along. I'm trying to write all the ratios out, and we are going to pick. Number 3, we have EC, or let me say CE, over BC, CD over BD. These are all the ratios that we have created. Okay. Let's go back to our question and retic all of this. Don't worry about the squared. We're going to figure out the squared. We'll get the squared. What lines are equal again? Let's write that out. So we focus only on the white. What lines are equal? CE is equal to ED, and BC is equal to what? CD. Lovely. Lovely. All right. Get a highlighter. So we are looking at the white ones, guys, just the white ones, and we'll walk through together. CF, EF. So CF over EF is actually BC over DE mathematically. I'll show you that we can do that. BC over DE. Let me write that out. CF over EF is equal to BC over DE. I think I have it. Do you notice it's squared? Let's square both sides. Let's square both sides. What will I have? See, you are allowed to do that mathematically, I'm sure you know. BC squared over ED squared. All right. Guys, I found it. I found it. Look at this. BC and ED. This examiner is sneaky. BC, ED. Is our CE equals to ED? Yes, I found it. I'm done. CD, it's messy. I'm going to explain, but I found it. Wait. CE. What did I say? Because what do I have? BC. No, I'm lying. No, I'm correct. Hold on 1 second. I thought I had it now. Ooh, la 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 la. What did I see just now? CE. Somebody, I think I had the phone that distracted me. BC equals to CD. But I want to get something. I want to get BC squared. Did somebody see something? I got a hand raised. Kwesi? Ooh, I thought I.
I'm lost by your third step. I'm lost by your third step, sir.
Which third step?
When you have CE over BC.
That's the ratio we got from here. This one. I just wrote it there. That's all. CDBD, EDC. I just transferred it here.
Oh, okay, sir. Thank you, sir.
All right. I saw something now, and my phone rang, and ooh. Okay, help me here, guys. And now you will see that when I say get the first ones correct, you see how important it is. Okay, from here, I want us to work. I squared both sides. Now, BC squared and ED squared. BC. So from the first one, I got this right. Okay. BC and ED. BC is the same as CD, right? Okay, I want to work from here, from number 3. From number 3. CE. BD. There's a card outside there that is just disturbing my concentration. BC and DE. There's something we're just missing, and then we would be done. ED, BC. Are they equal? No. CE. CE is the same as ED. Yes, anybody?
Sir,
CD
why
squared.
are you not having BD over DE?
Where?
Why is it BD?
Where?
By your fourth step, sir.
Why am I not having what?
BD over DE.
How? From where? You mean here?
Yes, sir.
Okay, from here I took it from the first one. I said CE over EF. It's mathematical. I'll show you what I did there. CE over E. I just want to get my answer first. Are you seeing what I'm doing there?
Yes, sir.
Top over top, bottom over bottom.
Okay.
Then I squared both sides because the examiner said it's squared. And that would give me BC squared over what? DE squared. All right? BC over CD. Can I just find this? Okay, just give me a moment, guys. I'm going to find it. BC and DE. I can't use the first one anymore. Do I have BC? Do I have ED? Okay, I have ED here. But C, okay, I have ED here. All right, ED. Okay, I'm just going to rewrite this letter to make it easy for us to see. Instead of ED, I'll have ED. Okay. So I have my ED here. Do I have my BC? My BC is the same as CD. Ooh, this is giving me a headache now. My BC, CE is the same as ED. ED there, all right. ED squared. Don't worry, guys, I'll find you. ED squared equals to what? EF multiplied by BD. Okay, EF. Now I'm moving away from the answer. I'm moving away from the answer. EF multiplied by what? BD. I'm moving away from the answer. My left hand side is fine. It is my right hand side. Oh, wait, guys. Everybody, let's focus on BC. We will be fine if we can find BC. If we can find BC, I'll tell you why I'm looking for BC. I already have my ED squared. I want us to find BC times BC. BC, look for anywhere you have BC, apart from equation 1, from 2 and 3. Let's find BC. And what is BC equal to? BC is equal to what? CD. Wait. BC. Okay, hold on. I think I have my answer. BC is equal to what? CD. And what is CD? CE. BC squared equals to CD squared. Do we have anything cancelling out? This is ED multiplied by ED. Don't worry. What am I looking for? Is CE equals to ED? Yes. All right, I got it. Oof. I know you are confused, but I got it now. Yeah. Okay. Everybody breathe in and breathe out. Shame. As keys. As keys. But here's my point. Here's my point. I got it now. Here's my point. Here's my point. Guys, my point is this. I want to go back to the whole question. Look at the whole question. Question 10. The whole of question 10. The first 5 marks, the first 3 marks, and the next 3 marks. Don't play with them. Why? The last one is not that it's not gettable, but under exam conditions, you may lose hope and you may lose the mark. I don't want to give you false hope. Although if I'm going to lose the mark, do you notice that I shouldn't lose my 533? Please talk to me and let me see if we're on the same page. Don't play around the first part of the question. Get it right. The last one may slap you left, right, and center. That's the one you leave and come back. I'll be giving you exam tips. I usually start my paper with Euclidean. The last one, I'll leave it. When I'm done, then I'll come back to it. It's always a bit tricky. So don't play with your 533. Okay, let me show you what I did. I got it now. But yeah, it took me some. So I had to use my prop theorem. And I used prop theorem. Okay. And which one did I use? I forgot now. I needed to prove BC squared. BC. Okay. I know I used this one. Then I squared it to get that. I left my ED. Then my BC. All right. I found it. Everybody, walk with me now. We are going to solve. Let me leave this whole page. We are going to solve it, and we are going to do it on a very clean page together. Clean page. Clean page. Now it's going to take us just a few lines. Okay, good. The first thing I saw, again, okay, so please let's go back. Don't worry about all the things I was saying earlier on, all right? But some of the things I said would work. So this is me redoing it now. Let's go back and look at the question and remark. Examiner wants CF, right? So please stay focused. I know I've messed you up a bit, but it's part of the job. CF, okay. We don't have it on our first ratio. EF, I see it's the side. BD, that's where my first Q is. BD is a base. When I have a base, I'm going to prove what? Similarity. Okay, so let's quickly prove that similarity. I'll start with angle F here. I'll also start with angle F here. Those two are equal, right? Angle C1 is equal to angle B1. Oh, we needed to prove that those lines are parallel. Oosh, so much work. Anybody remember how we proved that parallel? Okay, we said what? Angle D2 equals to angle C2. Proven. I'm going to ask you step by step as we go on. BD is parallel to CE. Alternate what? Angles. Are we okay with the first 2 points? So we don't come back. Are we okay with the first 2 points? Let's make our response very fast. Okay. So now we are working with proving that those triangles are parallel. I'll then come and say angle F is equal to angle F. Then, since my lines are parallel, we can therefore say angle E2 is actually equal to angle D. Corresponding what? Angles. If you like, please make sure you are following the triangles. Angle C is equal to angle B. You can also use that. Don't mix the one on the left with the right. Therefore, follow the order. Triangle FEC is similar to triangle FDB. Angle, angle, angle. Talk to me. Are we okay? I need to make sure we don't come back here. FE2 is equal to D. That's the first one. And then C1 is equal to B. So triangle FEC is similar to FD. The order, very important. Order, completely important. We're good. Once you prove similarity, let's write our ratio. All right, FE, but let's write it in order alphabetically. It's FE, but I'm writing EF over DF. We okay there instead of FD, right? Equals to what? EC. Which one comes first? CE over DB, but we know it's BD. Last one, FC, but we write alphabetically, and FB, BF. Similar triangles. Are we okay? Are we okay, everybody? Lovely. Okay, now we start combining. What did we combine? We're looking for CF and EF. I'm going to mark it. I'm looking for CF and EF. Was that what I did? Eban. Okay. So if I take those two out, EF over DF looks different from what I did, but it's fine. CF. Everybody okay? 1 second. I just want to check. Is that what I did? No. Oh no, I did it from prop theorem. What am I doing? CF over BC. Ah, no, I did it from prop theorem, man. Okay, because, all right, you notice I'm having DF here, and that is not helping me in BF. That's why I noticed something is wrong. Okay. So I'm going back to my thingy, prop theorem. Because I see that what I did there is not making sense. Because I want this ratio. Where's my ratio again? Come with me. Sorry about that. I want my number one ratio. You see, this number one ratio is what I want. Because that's what led me. CFBC. CFBC. EF. Sorry. Okay, it's part of the job. I want this ratio because this ratio gave me that. And that made it a lot easier. My bad. Sorry. Okay, it's part of the job. That didn't work. Proportionality, what do we have? CF over BC equals to EF over DE. Proportionality what? Theorem. Which lines are CE parallel to BD. There was something I cleaned which I shouldn't have cleaned. We were not given those lines as parallel, so we needed to prove that they are parallel. How did we prove they are parallel? D2 is equal to C2. Therefore, BD is parallel to CE. Alternate angle. That we did. All right. Sorry about me going the wrong way again. Are you okay with my proportionality theorem? Are you okay? Let's come back to this page. Are you okay with my proportionality theorem? Beautiful. Why proportionality? Examiner wants CF, which I have, EF, which I have, right? DE, which I have, and my problem is BC. Great. We are now there. I did something earlier on which was mathematical, but I won't. Let me go through. Can we cross multiply? What do I have? DE multiplied by CF equals to EF multiplied by BC. Guys, my aim is to get CF over EF. Now I can get it from here. But if you did what I did earlier on, you are good. Divide both sides by EF. What do you have? CF over EF. Now on the right hand side, I'm left with BC. Then take the DE there. Let me know if we are okay with that line. Are we okay with that line? So mathematically, I could say top over bottom. You are allowed to do that. Okay, let's square both sides now. Why am I squaring? I'm allowed to do that as well because I see the examiner saying CF squared over EF squared. So I'm allowed, as long as I'm doing it on both sides, it's allowed. So what do I have? CF squared over what? EF squared. BC squared over what? DE squared. But this is where the answer is. But BC is the same as CD. That is given. First line. Do you see that, right? Let me know on this page if everybody's okay. Quickly. From line 1 to the end. Okay. That's where the answer to this question is. BC is the same as CD. And we already have CD squared. Do you notice we have CD squared? If I square both sides, BC squared, therefore, is the same as what? CD squared. Let me see if I can squeeze that here so that I don't have to go so far. All right, watch this. Oh, I can then replace CF squared. Instead of writing BC squared, this BC squared, I'm going to write CD squared, which we have from 10.2.1. CE over multiplied by BD over what? DE multiplied by DE. Did that make sense to you? When I say DE squared, I'm saying DE times DE. Let me know if we are on the same page. BC is CD. So if I replace anywhere I see CD, I could simply replace it with BC here. Because they are equal, so squared will be the same value. I have everything I need except I don't need CE, and I need one DE to go away. Are those two lines equal? Absolutely. We did that earlier on. Tangents drawn from the same point. Proven. We did that earlier on. Oh, so I can therefore say CF squared over EF squared. Instead of writing CE, I can change it to DE. Yes?
So I'm lost when you have CE times BD over DE times DE.
Crazy. Why are you responding late? I need you to quickly respond before I go to the next point.
Sorry, sir.
What is BC? CD.
CD.
So come back to the question. Do you notice CD squared?
Yes, sir.
But what is CD? BC.
So it's CE times BD.
Yes, but CD is the same as what? BC.
Yes, sir.
So instead of writing BC squared, I'm writing this exact thing here. Does that make sense?
Yes, sir.
Again, we're given that this and this are equal. So anywhere I see CD, can you see what I'm saying? I can write what? BC. So instead of writing BC squared, I am now writing as what? CE multiplied by BD.
Yes, sir.
Okay. All right. And now I check what I want. I want BD and DE. The only thing disturbing me is what? CE. And I'm checking, is there a relationship with these two? Are they equal? Yes. CE is equal to ED. Tangents drawn from the same what? Point. So I'm replacing my CE with DE so that I can 6 marks. Cancel out. It's not an easy one. It's not an easy one. But did it make sense to us? You've got to go back and look at this question. And guys, it's about the skills that I'm applying. It's about the skills that I'm applying. It's not an easy one. Hence, your first 3 questions, you cannot play with it. The last one is going to be challenging. Yes, Kwesi?
So, okay, now how do we get DE times DE?
DE squared. What does DE squared mean?
Oh, multiplication of both of them. Okay, so I see. Thank you, sir.
Yeah, so it's not quite an easy question. There's a lot of manipulation that I did there. It's not very easy. I'm not going to lie to you and give you false hope. But you understand my point. Don't get the first ones wrong, because the last one is not going to be very friendly sometimes. And sometimes it's very doable to just walk through. All right, that was quite a tricky one, and I love challenging myself, and challenging you as well. But are we okay? Did it make sense? You've got to go back and look at it. Remember, it's not about the answer. It's about the skills that lead to the answer. It's about the skills that lead to the answer. Sometimes you might not get the entire 6 marks, but you'll be able to get 2 or 3 because you have written important things. Remember, no false hope, but it's doable, takes extra time, and in an exam condition, you don't really have much of the time. So the other ones, proving similarity and all of those, use the skills that I taught you, get an answer and move on straight. Okay, I think that was the last question. Yeah, it was a good one. I love it. I love every bit of this question. Okay, let's go to another paper. That was it. Let's go to another paper and see again. We want simple ones that we can quickly get. Okay, let's see. Simple ones that we can quickly get in the paper, and then the difficult ones that will take us some time. The simple ones, you must get it. For example, I think this one is gettable. Do you want to try this for me for 6 marks? Guys, if we have to extend till 8, it's fine. Want to try that for me? Six marks. I'll give you, let's see, 10 minutes. Let's try 10 minutes. Quickly, everybody, 10 minutes. right, guys, you had enough time to get the value of x. Anybody? Thumbs up, thumbs down. Hey, Victoria, beautiful. Ah, Bukayo, lovely. Come. Venusia, Lynn. Oh, you guys are giving me thumbs up just like that. Come on. If you didn't get it right, please don't be ashamed. Give me a thumbs down. Okay, Naledi. All right. Shamil, Sipati, Oratile. Okay, Denche Kwezi. Those of you that gave me a thumbs up, do you want to share what you did? Let's read first before somebody would give me an idea. In the diagram below, ABCD is a cyclic chord. Highlight your cyclic quadrilateral. Please, when I give you a question, learn to draw it out in your book and highlight. Already by doing this, there are things that I have seen. There are things that I have seen just by doing this. I don't know if it's going to lead me to the answer, but I already know that this is 3x. That one I already know. That is 3x. I think, yeah. And if that's the case, I already have my B1 and I have my, I think I'm done. All right. AFB is 2x. What are we looking for? The value of x. My thought pattern, before I allow somebody to speak, is I'm looking for the value of x. All I need is to get that. Check that. B2, A, and F would give me 180. Can I then find B2? That is what I am going to do. And I think I already have an idea. 6 marks. Anybody? You may not have gone my own way. Is there anyone who would like to share? Victoria, shoot.
Okay, sir. Sir, I used like a different method.
Oh, you used what?
I used a different method, like a completely different method.
Okay, shoot. Come, talk to me.
Okay, so first I looked at two different triangles. So triangle BCE.
BCE, all right. Let's call it the red triangle. Let's call it the red triangle. Okay.
Yes, triangle BCE and then triangle CDF.
CDF. Okay, let's call it the blue triangle.
Okay.
Okay, beautiful.
Yes, sir. And then I looked at the red triangle first.
All right.
And I said angle E plus angle B1 plus angle C1 will give me 180 because of some of the angles in the triangle.
Okay. Let me just write your thought pattern down. E plus B1 plus C1. Okay, 180 degrees. Yes?
Yes, sir. And now we know that C1 is equal to 3x.
C?
1
Okay.
is equal to 3x because of the exterior angles of A is like the quad is equal to the opposite interior.
Okay, so can I do this for you already?
Yes, sir.
Okay.
So then I made B1 the subject of formula.
Okay.
And I got 180 minus 4x. So B1 is equal to 180 minus 4x.
All right.
Then I moved on to the blue triangle.
Okay.
And F1 plus C3 plus D1 is equal to 180 degrees.
Okay, equals to 180 degrees. Yep.
Yes. C3 is 3x. I use vertically opposite angles or opposite exterior angles.
Okay, 3x, vertically opposite there. Can I do this for you already?
Yes, sir.
Okay.
Okay, plus D1. Yes. So 5x equals to 5x plus D1 is equal to 180. Then I will do the subject of formula.
All right, so D1 equals to what? 180. Yep.
Yes, sir. And then because we have the cyclic quad, I said B1 is equal to D2.
Okay. B1 is equal to D2. We all agree with that.
Yes, sir. But we know that B2 plus D2 is equal to 180 because of sum of opposite angles in the cyclic quad.
Which one?
B2 plus D2.
All right, B2. Okay, let me come here. B2 plus D2. I hope we are following some of opposite angles, cyclic quad. Yes?
Yes, sir. Then I got B2 is equal to D1.
B2 is equal to D1. Exterior angle.
Yes, sir.
Okay. We're here.
And then, yes, from that, sir, I got that I made D1 the subject of formula, and so I got B1, 180 minus B1.
Huh? 180?
Minus B1.
Wait. We said what? You said D1 plus D2 equals to what? 180. Is that fine?
Yes, sir.
Then,
No, B2 sir. Then I said B1 plus D1 is equal to 180 because B2 is also equal to D1.
B2, hold on, B2 is D1, right?
Yes.
Okay, these two are equal. Then you said what? Let me clean this one. Yes, I'm with you, Vic.
Yes, and then I got B1 plus D1 is equal to 180.
Angle B1
Plus D1 because B2.
Wait, I want us to get your connection.
Yes, sir.
B2 plus D2 is 180.
Yes, sir.
Opposite angles of a cyclic quad. I agree with that.
Yes, sir.
Then you said angle B2 is equal to angle D1.
Yes, sir.
Okay, let me put a dot there. That I agree with.
Then, because like I manipulated it, I got that B1 plus D1 is equal to 180.
B1 plus D1. Let's see, will that be correct? Let me find a reason. B1 plus D1. Let's prove that that is equal to 180 before you continue. Okay, let me help you there. B1 plus B2 equals to 180, right?
Yes.
Angle on a straight line. D1 plus D2 is also equal to what? 180. But B1 is the same as D2. B1 is the same as D2. Exterior angle. And you want to prove that B1 plus D1.
Yes, sir.
So instead of writing D1, D1, okay. All right, there we go. That's what she's saying, guys. D1, because B1 is the same as D2, right?
Sir.
So is that what you're saying? D1 plus B1 equals to 180, right?
Yes.
Okay, from here?
And I made D1 the subject of formula.
So D1 equals to what? 180 minus? Yep.
Yes, sir, but we see that earlier on B1 was equal to 180 minus 4x.
Okay. Can I replace it here for you?
Yes, sir.
So what is our B1? 180 plus 4x.
Yes, and D1 basically equals to 4x.
D1 now
Then
is 4x. Yep.
Yes, sir. Then I substitute back into the formula of the blue triangle.
Okay. Can I replace it here for you?
Yes, sir.
4x equals to 180 minus 5x.
Yes, so I carried the 5x over and I got 9x is equal to 180 and then I divided it by 9.
And that would give us what, 20?
Yes, sir.
Okay. Wow. Thank you, Victoria. 20. Did anybody do it in a different way? All right, Bokayo. But guys, did you follow what Victoria did there? All right, as I was writing down. Bokayo, shoot.
Okay, so I started saying C1 is equal to angle C1 is equal to angle A.
Angle C1 equals to angle A. All right, C1 equals to A, which is 3x.
Yes.
Okay.
And then I said angle B2 is equal to angle C1 plus angle E.
Angle what? B2.
1.
C1.
B is equal to C1 plus
Okay.
angle E.
Exterior angle of a triangle.
Yes. So, and then I got B2 as 4x.
All right, so B2, since we know C1 as 3x, and we know E as x, so B2 equals to 4x. Good, shoot.
And I said in triangle ABF,
All right, triangle ABF.
angle A plus angle B2 plus angle F is equal to 180 degrees.
Beautiful. So what's our angle A?
Angle.
3x.
Yes.
B2 is 4x.
Plus 2x.
All right, beautiful. So 7 plus 2. We come back to the same 9x equals to 120. Beautiful. Good job. Well done, Vic. Well done, Bokayo. Somebody else with a different approach? Anybody with a different approach? So guys, with these two approaches, do I still really need to do this? I don't think so. I don't think so. Did this make sense? Is there anyone who is still lost? Let's see. If you are still lost, give me a thumbs down. We have two powerful approaches from you guys. Where are you lost? Crazy?
So from what the second guy spoke on,
Okay.
I think from the second step,
Do you know the rule that says exterior angle of a triangle equals to sum of opposite interior angles?
yes, sir.
Good. So he looked for B2, which is exterior. Exterior angle, let me use a red highlight. Exterior angle is equal to sum of these two. And that's why we have 3x plus x. Does that make sense?
Yes, sir.
So now he came back and said, if this is 4x, now I have 3 angles that make up a triangle. Yeah, the rest is maths now. 4x plus 3x plus 2x equals to 180. Are you still lost?
Which is nice. Yes, sir. Yes, I see.
Okay, so that was what he did. All right. What I would have done is quite similar, because if you notice, the first thing I said was, if this is 3x, that is also 3x. All right. And same thing like Bokayo said, the idea is to, and I even explained that the idea is to look at this triangle, and my aim is to find B2. And you can find, if you don't see this as checked, in case you don't see this B2, look at this, B1 plus B2 would give you 180, right? In case you don't see that second line, all right, I'll write out the reasons. But in case you didn't see that, look at this. Let me help you. B1 plus E plus C1 would give me what? 180. What is B1? I don't know. X, what is C1? 3x. Do you notice what my B1 is? I think Victoria did something similar to this. 180 minus 4x. But B1 plus B2 equals to 180. What is B1? 180 minus 4x plus B2. Do you notice the 180? The 4x moving over. And that was what he did here in one step. By using exterior angle of a triangle is equal to sum of. So you must know this. It's actually a shorter step. Now B2 equals to 4x, and then we go into the big triangle and we are done. Is there anyone who still needs help? Anyone who still needs help? Beautiful 6 marks. Well done, Vic. Lovely. I'm glad you went around and round and round, but you still got the answer. That's very, very important. Getting the answer is key. Okay, everybody looks okay, and you can do the writing up, especially the reasons. Please make sure you write all the reasons. Sum of angles in a triangle, exterior angle of a cyclic chord is equal to opposite interior angle. Beautiful. Lovely, guys. Thank you. I don't want to waste so much time again because you had 10 minutes to think through this. Beautiful. So try to go through the question again and walk through. Let's move on. Guys, I'm going to skip this proof now. Everyone should know this proof, please. Ooh, here we come. Here we come. Here we come now. I think this one is quite nice because I see that it's the first mark is the 6 marks there. Let's read together and you're going to tell me the angles that are equal to x. In the diagram, M is the center of the circle. A, B, C are points on the circle such that AC, always watch the lines that are equal. AC and BC are equal. Okay. First, once I see that, you know what I'll do? I'll just put a letter. Okay? Okay, they've used X. I'm going to put a letter there. Those two angles are equal. Just leave it like that. You don't know what, don't use X again because they have X on the diagram. PQ is drawn parallel to CA. Okay, I see parallel lines. Maybe it's going to lead me to proportionality. We'll see later on. All right, but I know that parallel, I should be thinking about fun angles. Okay, which one is a tangent? PA. Where's my PA? All right, PA is a tangent. Let's keep that there. BC produced meets PC and da-da-da. Let Q be X. Guys, I want 4 angles. That's grade 11. 4 angles that are equal to X. Come, let's shoot. 4 angles. Let me assist you with something here. 4 angles that are equal to X. I'm sure this is a lot better now. 4 angles that are equal to X. You have 3 minutes. Write the ones you can see. Write the ones that you can see. Once you are done, give me a thumbs up. Write the ones that you can see. Oh, Linda, you're done. Beautiful. I'm going to show you a skill here that I wrote on the skills I gave you. How to get these answers very fast. Here you must get it quickly. Chop, 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 chop. How to get these answers very fast. I'll show you something that will help you. Remember this point? These 2 points will help you get the 4. Bokaya, you have your hand raised. Talk to me.
So how many?
4. We're looking for 4. You'll see how just these 2 points alone would give you all the 4. In case you did not get it right. Sepati is joined, done. Simeka joined, thank you. Ratili has joined in. Can I see again those of you that are done? Let me see again. Just want to see the names. All right, Susan done as well. Beautiful. Susan is done. Let's see who else is done. Fatima, are you done? Sweet, beautiful. Mashallah. Venusha, also you said you were done. That's beautiful. Denche. Oh, Awande, that's lovely. Thank you, you're done. Denche, are you done? Let me see. There are some other names that are hidden here. Denche, you done? Great. Is Mohammed still there? Let's see. Shamil, talk to me. Where are you struggling? Which one is remaining? Kwesi, are you done? How many do you have now, Kwesi? 2 are remaining. Okay. Let me show you something, how to get this one done as quickly as possible. These 2 points that I wrote are in your notes, right? I gave you 10 tips. Trace the source of the angle. Let me save the 54 seconds. I need that time. Check. Examiner said I should look for x. The first thing I have a tangent here. No, I have this line is parallel. Instantly know that fun angle is involved, right? Okay, it's either F, U, or N. If I want to trace, okay, there's no other part. Oh, this is my second parallel line. Do you notice I have my A1 already done? Corresponding what? Angle. Look at the line. This line here, oh, is equal to that. That is done. Right? Always write the things that you have. We're told that what? AP is a tangent. Oh, beautiful. Look at my tangent and the chord. Where is the chord going? The chord is going to angle B. So that is equal to X. That's the third one. All right. Connect this line again. Just check the lines that are by the side. Can you see? Parallel. Oh, trace it again. Where is my parallel line? Ta, ta, ta. Done. I have my 4. Did it make sense? Did you get the 4? And you have the reasons. A1 is equal to X corresponding. All right. Thank you for the... Angle B is equal to X. Yes, Bukayo, talk to me. You have something else?
So, no, I just wanted to clarify something.
Okay.
So, theorem only works in
Sorry?
sine chord theorem in circles.
Yes, because a tangent cannot be drawn when there's no circle or a curve.
Okay.
All right. So we have our first 4. Everybody okay? Beautiful. Please don't forget your reasons. Let's run. Prove that ABPR is a cyclic chord. We wrote down 3 important things. Now, ABPR, already the examiner is telling me it's a cyclic chord. A, B, P. I don't know if you see, this one is already done. If you remember the three things I told you about the cyclic chord, this one is already done. Can somebody just shout the answer here? Why? What are the three things? Kwesi, what do you mean by R3? What are you saying about R3?
Sorry, there was a mistake.
Okay. What are the three things about the cyclic chord, my dear learners? Opposite angles are supplementary. Exterior angle is equal to opposite interior angle. Angles in the same segment. Can you figure out angle in the same segment here, everybody? Angles in the same segment. Can you see it? Angles in the same segment. That angle and that angle. So I'm done. Angles in the same segment. A2 and what? Not A2 and P. A2 and P are not in the same segment. Because, check here. Let me see. A2 and P. No, it's not A2. A2 is right here. Those ones are alternate angles. They must be in the same segment like that. Do you see that? Crazy, are you fine with me there? All right, guys. What's the reason? Here you are using the word converse. Anytime they ask you to prove that it's a cyclic chord, you are using what? Converse. So I'm not going to write this. I'm sure you are okay with that. Converse. Angles in... Okay, do you want to try the third one for me? Prove that BA squared, no, BA over BQ, I want to write it here on this big one. 3 marks, so I don't think it should be very heavy. BC over QR. BC over QR. Oh, lovely. 3 marks, come. I'll give you 5 minutes. Find a way out. Don't get a 0. Trace it out. Yebo.
So proving BA over BQ equals to BC over QR.
Yes.
Okay, thank you.
Okay. I'm just checking something here. BC over QR. Okay. Anybody done? Okay, Linda Kutle. Susan done. Beautiful. Trace the lines first. Trace the lines first. It's going to assist you. Remember the skill. Guys, don't just run into a question blindly. I've taught you to trace the lines first. Twenty seconds left. All right. Can we see? Thumbs up, thumbs down. Thumbs down, thumbs up. Come, respond. Okay, beautiful. Lovely. Fatima, Linda Okwezi. Venetia, we good. All right. Sina, you've been quiet now. Talk to me. Gracia, you've also been quiet. Okay, what would I do? Sipati, I didn't see your hand, so I don't know whether you're in or not. But look, follow the question. If I follow what the examiner has, that's what I do first to see the nature. BA over BQ. Okay, interesting. Don't forget those parallel lines. I see that triangle with parallel lines. Ah, that actually gives it away. It's proportionality. BA over BQ must be equal to what? BC over BR. And that actually answers 95% of the question. BA over BQ. Already my left hand side is done. BC over BR. My problem is BR. What is this? Prop theorem. Which lines are parallel? AC. Parallel to what? QR. So my problem is BR. If I compare it with the question, examiner is telling me that BR is the same as QR. Go and look at the lines and find a reason. look at the lines and find a reason for those two to be equal. BR and QR. That's my QR and that's my B. Oh, beautiful. Do you notice that angle X, angle X? Isosceles. So QR is the same as BR. But what is your reason? What is your reason?
Angles of equal sides. Angles of equal.
No, it's the other way now. We're talking about sides, right? It is sides opposite what? Equal angles, because we are referring to sides. Make sense? Rati?
Yes, sir.
All right. So if I was working with angles, I'll say angles opposite equal sides. But I'm working with sides, so I say sides opposite equal what? Angles. Everybody okay there? We're done with that question. Beautiful. Beautiful. That wasn't bad. Okay, we have another one. Let's check this one together. You do have this document. I sent you 3 documents. TCR is a diameter. I am going to stop there immediately. What can you tell me, guys? Please. Why am I stopping there? Oh, diameter of the largest circle. What can you tell me? Look at the diagram. That word tells us something important. TCR is the diameter of the largest circle. There's something that this gives me. Talk to me, somebody. Samika says Q1 plus Q2 is 90 degrees. Perfect. Can somebody give me the reason? Somebody give me a reason for saying that?
Angle in a semicircle.
Beautiful. Angle in a semicircle, guys. That's how we work. Now, chord TQ, let's look for TQ. You see, guys, I'm not reading. No, taking my time. TQ of the largest circle cuts the smaller circle at M. Okay, that's not important. PQ is a common tangent. Where's PQ? Common tangent to both circles. Okay, PQ is a common tangent to both circles. All right, that's a very important statement. PQ is a tangent to both circles. Makes sense. Okay, I already see a chord, tan chord there, but we'll find out. RP is perpendicular, that is given, and MS is parallel. Okay, we have those two information. Come, let's run for the questions now. Everybody, give stating reasons why SQ. Okay, we have 9 marks to get. Wait, I cut out something important. I want us to get this first 9 marks, 3 and 6. First one is 3. And the second one is 6. Why is SQ? Proof given reasons. SQ is the diameter of the smaller circle. Where is SQ? Why is SQ the diameter? Come, 3 marks. Proof given reason that SQ is the diameter. Use the if statement. Why is SQ the diameter of the smaller circle? Anybody? I'm going to ask you to use the if statement. If SQ is the diameter, then what? Of the smaller circle. Do you notice that angle M2 should be 90 degrees. Do you agree with me? If SQ is a diameter, then M2 should be 90. Do you agree? Our job now is to go and prove that M2 is 90. Mind you, TSR is the diameter of that, so that is what? A center there. Can we prove that M2 is 90? PQ is a common tangent. Oh, this examiner is cheeky. This, wait. I'm seeing something here. This examiner is very cheeky. Can I prove that M2 is 90? This is a radius. That's a radius. That's a radius. That's a tangent. This is 90. Tangent rad. 90. Okay, I think I have something. 1 second. Wait, parallel. Oh. Okay, talk to me. Somebody had a hand raised. Bokayo?
Oh, no, so that's what I wanted to point out.
Oh, okay. All right. So you can see that the if statement is working, because we're saying if SQ is a diameter, then M2 should be 90. And I'm seeing there's a parallel line here, tracing it over to that parallel line, co-interior. If that's 90, that's also 90. Did that make sense, everybody? If statement has never failed me. Okay, so I'm going to start with Semica's one. Q1 plus Q2 equals to 90 degrees angle in a semi-what? Circle. Now, M2 equals to 90 degrees co-interior angles. MS parallel to QR. Therefore, SQ is a diameter. What's your reason? I'm using the if statement. Converse angle in a... Can I see if you're lost? Let me know. Anybody lost? Quickly, because we don't want to come back here. Did it make sense to you? Can I see your response? Thumbs up. Did it make sense? The approach and everything. And I get a response from everyone. I don't think so. Grace. All right. Crazy, did I get a response from you? Ratili, well done. Vukudo, did I get a response from you? Are you okay? So guys, the skill is what I'm trying to show you, remember? Once they say prove the nature of a line or a shape, bring in your if statement. Now, don't be scared. I know some of you are already saying, 6 marks. Yo. What are we going to do? Let's try. RT equals to RQ squared. Let's first look at those lines. Don't worry, I'm here to guide you on those 6 marks. RT, let me use the blue one. Where's RT? Let's first look at those lines. RT, okay. No, I'm lying. RT squared, okay, equals to what? RQ squared over RP squared. Now, the first thing I'm going to do here, I want to work backwards. Could this be possible? For me to get RQ squared, I have to have RQ over RQ. I'm working backwards. And then RP, see if I cross multiply the RP, RT, and RP. May I ask if what I just did made sense to you? I want to work backwards. If I cross multiply, RQ squared equals to RT times RP. Did this make sense to you? I'm trying to work backwards. That's the first thing that I'm thinking. Crazy? Maths. Cross multiply. RQ squared equals to RT times RP. Are you okay with that? Unmute yourself quickly. Unmute yourself.
So I'm confused.
Where are you confused? Talk to me quickly.
When you have RQ over RT equals to RP over RQ.
Do you notice if you cross multiply this, you're going to get that back? You see, you're trying to be creative here. That's what I'm saying.
Oh.
Work backwards. So for me to get RQ squared, it must be, can you see that?
Yes, sir.
So if I cross multiply, and why am I doing this? If I can get 3 letters out that form a triangle, I am done.
Yes, sir.
So if I look at this, all right, if I look at this side, what do I have? What's 3 letters? R, Q, T. Is there a triangle like that? Yes. Oh, 6 marks is in the bag. R, What about the one on the right? R, P. These are the 3 letters. Do I have that? I'm going to ask you to do something now. R, P, Q. R. Guys, I'm already done with this question because I see what the examiner did. The examiner is going to get this ratio from these 2 triangles if I can prove that they are similar. Is the idea making sense? Working backwards. Can I ask you to prove that those 2 triangles are similar? Quickly, I want you to try. Prove that those 2 triangles. Now, it's not in order here. You have to put it in order because they didn't give that to us. We formulated it. So, can we prove that those triangles are equal? Quickly, everybody. They are not in order. RQT and RPQ. The 3 triangles are not in order. I have R. What do I know? I have 1 triangle like that. But fortunately for us, we have this. So this is T, this is Q, and this is R1, T, and Q. So I know that one. And the second one, RPQ, the one outside here. So your job is to, I already have 1 side that is equal to each other. I don't know if you see that. This is R2, this is Q, and this is P. Already I have angle P is equal to angle Q. You just need to find 1 more. Please find 1 more for me. Anybody done? The third activity, I'm going to allow you to do it. So we're going to look at, listen, our third activity, we would look at it for 45 minutes in our next session, but I wanted to explore, and then we would start analytical geometry grade 12 on the same day. So what the third activity sheet, You run through it. You have enough time to run through. I'm just going to come and we mark 30 minutes or so. I'm not going to give you time to do it. You should have done it before the next class. And then we move on to analytical geometry, grade 12 section. Grade 11 was done. Yes. Guys, are we done? This question is done already. This one is done already. Done. I know you're tired now. It's been 2 hours of headache. But let me assist you here. Please check. I have already done the big work by thinking for you there. Now, if I compare, do you notice I am trying to look at RQT, not in any order, and I'm trying to look at what? Triangle what? PQR, not in an arranged order. I have R1, I have Q1, which is Q1 plus Q2, and I have angle T. It's not in order. I have P2, I have Q3. No, sorry, I have R. What am I doing? I have R2 and I have P. Let's get the angles. What do I notice? On the side, that is 90 degrees. P is also 90 degrees. That is done. Q3 is equal to T. Do you agree with me? Everybody look at those two. Tan chord. Do you agree with me? That is a tangent. What's my tangent again? PT is a tangent, and that's a chord. Where is that chord going to? Do you see that? But this angle, now I can reorder my angles. Now that I know that those angles are equal, check what I'm going to do. I am now going to order them. This space is even too big. Let's see. Angle T is equal to angle Q3 tan chord. Then angle Q1 plus Q2, or you can label it TQR. TQR is 90 degrees, angle in a semicircle, and angle P is 90. That is given. Now the angle on the left hand side, please guys, what you write on the left hand side is very, very important. And now, so I'm done with this and this, I'm done with, so I'm left with R1 and R2. The left hand side angle, and I would say third what? Angle. Therefore, T, triangle T in order must be similar to triangle what? Which one is on the right hand side? Q, P, and R. Angle, are you okay there with that before I move on? I think this is the last question for today. Are we okay with that? Do you see what I meant by it's not in order? If they give you to prove that it's similarity, then it's in order. If you are the one proving, then it's not in order, you've got to arrange it. Now that I have this arranged, can I write my ratios, everybody? I'm going to clean this rough work, because it was just a rough work, and I will move this upwards. Come, let's get those 6 marks. TQ over what? QP is equal to, what do I have? QR over PR, which is what? TQ, no, TR rather, over QR. Remember what I want. I wanted to get RQ. Oh, here. Similar what? Triangles. Do you see my, do you notice I'm done? That's my reason. Cross multiply, what do I have? RQ squared equals to what? TR multiplied by PR. I can then divide both sides by PR, just the way the examiner wants it. TR will be what? RQ squared. Check the 6 marks. Did it make sense? Again, it's in the skills. So the tips. Do you notice I am not doing anything outside my tips? When you are given an algebra, work backwards to see the triangles used. Once the triangles exist, similarity, ratios. Watch out for lines that are equal, and you're done. Okay. I hope this is the last one. I know I've tortured your brain. Oh, I've tortured your brain today. Sorry. It's the nature of the beast. What are we doing next? Let's quickly get the last one. I see the 6 marks question. I am so sorry. Okay, it's a 6 marks question. If MS is equal to 14 units, okay, let's see what they are up to, because I see another 6 marks question. If MS, it looks messy, you would have to forgive me. Let me use deep green. If MS is equal to 14 units, PQ, where's PQ? The tangent, root 640. Calculate the length of the radius of the larger circle. Radius of the larger circle is TR. But let's start from where we were. Where were we? Where were we? What ratio did we have? Let's start from there. Let's see, will that help us? What do we have? RT equals to RPQ squared. Let's write that down first. That might help us. RT equals to RQ squared over PR. Let's see if that would help us. Let me see, did I get it right? Okay. Now they give us MS, which is not there. What are we looking for again? The radius of the big circle, which is TR. Okay, so we are looking for this. Fine. RQ. RQ squared. Okay, which is this. And what? PR squared, which is that. Okay. Let me help you here. I see an answer as quickly as possible. I'll guide you. Because of time, I know you're tired. My good learners, this is not an easy topic, but consistency of practice will assist us. Look at this. Look at what I'm seeing. I'm seeing something there. You might not see the triangle I'm drawing. I'll help you. TSR. And I want to tell you why I'm doing what I'm doing. Do you notice I put a dot and a question mark there? If I can get QR, then I'll be able to get RP. I don't know those two, but here's what I saw quickly. These two lines are parallel. Theorem number 1, a line drawn from center that is perpendicular will do what? Bisect. So that is equal to that. This is a radius. I don't know if you see midpoint theorem. My good learners, that is midpoint there on the left. That is midpoint on the right. Already midpoint theorem is done. Midpoint on the left, midpoint on the right. Those lines are parallel. If this is 14, this is going to be 28. You don't even need to state so much things. QR is 28. Midpoint theorem. Does that make sense, everybody? We spoke about that. All right? You would notice something about midpoint theorem. Here's the deal. This is half of the long side. This is half of the long side. The base is half of the base. Once I write midpoint theorem, every other thing is done. Now, consider this. Do you notice I can use the theorem of Pythagoras on that side? Because it's a right angle triangle. Triangle what? PQR. I can then say what? QR squared equals to PR, because I'm looking for, remember, everything I'm doing is because I'm using the old formula that we got. We are using this. Do you notice I already have a QR, 28 squared. That one is done. What I'm looking for now is PR, but I see that it's a right observation, right angle triangle. So I'm done now. What is my QR? QR is 28, so 28 squared. What is my PR? That's what I don't know. But what is my QP? Root of 640. Do you want to give me PR, everybody? I'm sure you can do this. You're tired. So 28 squared minus 640, because the root cancels that. Ah, beautiful. And then I look for the square root of that. PR is 12. Please make sure you write the reason here. Pythagoras. PR is 12. Now that my PR is 12, I don't know if you see that we are done. I can now come back here. I'm looking for the radius of the big circle, which is what? RT. What is my RQ? 28 squared over what? 12. And we are done. Any question? Please talk to me. Let me take your questions on this before we shut down. 65,3. RQ squared, which is 28, yep, over 12, 65,3 units. Talk to me, everybody. Is there anything you feel I lost you on this question? Fatima, you okay? Kwesi, you're good? Can I get a response from as many people? Party, you okay? Dencho, you're right? All right. Awande, everybody's okay. Ratile, you okay? Simeka, you're right. Sina, are you okay? I didn't get Grace. Are you okay? All right. So, guys, you would notice that it's more of the skills, and I'm not using anything different from what I gave you. Okay. I'm not using anything different. Tracing the source. When I'm giving the base, I'm trying to use the similarity. When they tell me to prove similarity, list the angles, make sure they are equal, third angle, and on like that. Nature of the angles, the tangent, the chord. Start by reading the question, and life becomes a lot easier. Did this make sense to you, everybody? I think we dealt with the last question on activity 2. Did this make sense? Are you okay? I know it's going to get a bit tricky, but it's getting better. Getting better. Getting better. All right. You are most welcome, Ratile. Everybody, we good? Have a lovely evening if there's no question. The lesson will be available quickly on the link that you have for you to rewatch. So when you are doing this at school, be the first. Apply these things. It can give you a good sign of revision. Thank you, Susan. Lovely. Well done, Bonkayo. Lovely. I heard those hands so loud. Simika, we're good. All right, have a peaceful night and keep well. Get ready for school again tomorrow. Good night. Remember, Activity 3 should be done. We'll mark in our next session. Bye, guys.